Hello students, welcome to my YouTube channel. I am Professor Monali Shirsagar, working as Assistant Professor in Kekewag Engineering College, Nasik. Today we will see complex integration. For this, first we see what is the singular point. Here, the singular point, if we consider the point z0, is called the singular point if the function f of z it fails to be analytic at z0. In simple way, if we got value of f of z is infinite or not defined, then the given function is not analytic. At that point, or that point is called the singular point. If we consider example f of z equal to 1 upon z minus 3, z minus 5. If we consider z is equal to 3, then here value of f of z becomes infinite. Then here z is equal to 3 is the singular point. Similarly, if here we put z is equal to 5, then again we got the value infinite. Therefore, z is equal to 5 is the singular point because at which the function is not analytic. Now we see the theorems to find the value of integration. First is Cauchys theorem. If the function is analytic on and within closed curve C, then the value of line integral over the closed curve C of f of z dz is equal to 0. Remember this. If the function is analytic on and within closed curve C, then the value of integration is 0. Next is Cauchy's integral formula to find the integration. If f of z is analytic on and within closed curve C, and if A is any point lies inside the curve C at which the function is not analytic, then the value of f of A is equal to 2 upon pi 1 upon 2 upon pi 1 upon 2 pi I line integral over C f of z upon z minus a dz. That is, if we find the value of integration, we got 2 pi I into f of a. If here the inside integral, the function is f of z upon z minus a raised to n plus 1, then we take the derivative, that is here value of f raised to n of a is equal to n factorial upon 2 pi I line integral over c f of z upon z minus a raised to n plus 1 dz, where this f raised to n of a denotes the nth derivative of function f of z. Now we see the examples, how to simplify the examples by using Cauchy's theorem or integral formula. Evaluate line integral of z square plus 1 upon z minus 2 into dz, where C is circle over mod of z minus 2 is equal to 1. Also calculate the value of integration for C. C is the circle, mod z is equal to 1. We see this one by one how to find the value of integration. Here first we take the function f of z. Here we consider f of z is equal to z square plus 1 upon here value is z minus 2. If we take z is equal to 2, then we got the value of function is infinite. That is, here z is equal to 2 is the singular point. Okay. Here we consider z is equal to 2 is the singular point of f of z. We check this point is lies inside the curve or outside the curve. Here this is point at which the function is not analytic. Here C is the curve mod of z minus 2 equal to 1. If you put z is equal to 2, then here we got 2 minus 2 is equal to 0, which is less than 1. That is, z is equal to 2 lies inside the curve C. And if z is equal to 2 lies inside the curve C, then we use Cauchy's integral formula to find the integration. Here we use Cauchy's integral formula to find the integration. Here a is equal to 2 is the point which lies inside the curve C at which the given function is not analytic. For simplification, we consider f of z is equal to z square plus 1 and a equal to 2 is the point which is the singular point. Now, by using Cauchy integral formula, we find the value of integration. We want the value of this integration. For this, we use f of a into 2 pi I. Now, we put the values and simplify. Here, f of a, here value of a is 2. Therefore, f of 2 is equal to 1 upon 2 pi I into the line integral over the closed curve C z square plus 1 upon z minus 2 into dz. Now find the value of f of 2. For this, substitute in f of z, z is equal to 2. Then we got z square is 2 square plus 1, that is 4 plus 1 is the value of integration. 4 plus 1 is equal to 1 upon 2 pi I into the integration z square plus 1 upon z minus 2 into dz. We want the value of integration. Therefore, here value of integration is equal to 4 pi 5 into 2 pi I. Therefore we got the value 10 pi I. Okay, this is the value of integration when z is equal to 2 is the point which lies inside the curve C. For this, we use the Cauchy's integral formula and find the value of integration. Now, similarly, try to find for over the curve C mod z is equal to 1. Now, check this mod z is equal to 1. Here, z equal to 2 lies inside or outside the curve C. If we put z is equal to 2, we got mod of 2 is 2 and this 2 is greater than 1. That is z is equal to 2 lies outside the curve C. Now, if z equal to 2 lies outside the curve C, that is the whole function, z square plus 1 upon z minus 2 is analytic on and within closed curve C. Therefore, by Cauchy's theorem, your value of integration f of z dz is equal to 0. This is equal to 0 by using the Cauchy's theorem. If the function is analytic on and within closed curve C, then the value of integral is equal to 0. In this way, we find the value of integration. We see one more example of this, how to find the integration. For this, we use the Cauchy's integration differentiation formula. Evaluate line integral over the closed curve C for the function 4z square plus z upon z minus 1 whole square dz, where C is mod of z minus 1 is equal to 2. For this, first we check for z is equal to 1, the given function is analytic or not. Here z is equal to 1 is the singular point and we check this is lies inside or outside the curve. Put z is equal to 1 in the interval in the curve C. We put 1 minus 1, we got the value 0, and 0 is less than 2, therefore z is equal to 1 lies inside the curve C. Now we find the value of integration. For this, consider the function f of z. Here we consider 4z square plus z be the analytic function on and within closed curve C, and here a is equal to 1. Here z minus 1 square. Here z minus a raised to power. Then here we use the Cauchys integral differentiation formula to find the value of integration. Therefore use the formula f raised to n of a is equal to n factorial upon 2 pi I line integral over c f of z upon z minus a raised to n plus 1. Here our value is z minus 1 square. Therefore we write z minus 1 square as raised to 1 plus 1 and find the value of integration. For this we got the value of n is equal to 1. Find the value. We put n is equal to 1. F dash of a is equal to 1 factorial upon 2 pi I line integral over the closed curve C 4z square plus z upon z minus 1 raised to 1 plus 1 dz. Simplify. Find the value of f dash of a. For this, find the derivative of f of z. F of z is 4z square plus z. We take the derivative, we got 8z plus 1. Substitute the value of z is equal to 1 and simplify. Here, if we substitute the value, then we got 8 plus 1, that is 9, is equal to 1 factorial is 1 upon 2 pi I into the integration. We want the value of this integration, therefore we can write this 2 pi I on this side. Then we got the value. Integration value is equal to 9 into 2 pi I, which is equal to 18 pi I. And this is the value of integration. In this way, by using the Cauchy's formula, Cauchy integral formula, and by using the differentiation formula, we can calculate the value of integration. We use Cauchy's theorem when the function is analytic in on and within a closed curve C. We use integral formula if you got any one point which is lies inside the curve C, which is the singular point, that is at which the function is not analytic, and use the differentiation formula. Use the differentiation formula when the singular point, if the function in the function is z minus a raised to r or n, this power is more. Okay, thank you for watching YouTube channel.